going to realize the Kirchoff's current law using a circuit that you're going to realize with Circuit Wizard. So we will open our Circuit Wizard straight away. So Circuit Wizard is already downloaded on my computer, so I use it straight away. So when you have the Circuit Wizard, to be able to realize the circuit, first go to the gallery, and in the gallery you will have a box here that shows, when you click on the gallery, you have a box that shows gallery. So click on that box and then go to the particular instrument or the particular components that you're going to need to realize the circuit. First, I'm going to need a power supply. So I go to the power supplies, and here I'm going to need a voltage source. So I go to DC voltage source. My circuit is going to use a DC source. So I go to DC voltage source. So after dropping that one, I'll pick the next component that I'm going to need. I'm going to need some resistors. So here we have resistors over here. So you click on it, and then you drag it to the right position that you want it to be. All right. So I'm going to need about 2 resistors. So I just copy and then I paste. Good. So now, apart from the resistors, I'm going to need an ammeter. So I'll also select my ammeter. If you want an ammeter, ammeter is an instrument. So come here, choose virtual instrument, and then select ammeter. Just click on it, drag it, and then you drop it. I'm going to need about 3 of it, so I just copy it, and then I paste it at the right position that I'm going to need it. Okay, and then the next one is going to be here. So if you don't like the position, you can just rotate it using the key that I just clicked on. Okay, so now from here, I can just connect my components to make my circuit. All right. So any kind of unwanted line, you can get rid of it by typing on the escape key on your keyboard. So any unwanted line, you can just get rid of it with the escape key. All right. So now my circuit is now well constructed. I would like to change the values of some of the components, like the voltmeter. I want to change it to 10 volts. So I'll just double click on it and then I'll change it to 10. All right. The resistor, I want to make it 220 ohms. So 220, and then you change the K over here, and then you have the 220 ohms. And this resistor, I want it to be 330 ohms. 330, you change the K. The K means kilo ohms. I don't want it to be kilo ohms, so I have to change the K to nothing over there in this box, and then I click enter. So I have it. So now I have every component that I'm going to need, and my circuit is well constructed. So I'm going to run my circuit to find out the current that I'm going to have. Okay, so my current are well given to me, so I can see the flow of the current also by typing or clicking this button. Okay, so now this is the flow of the current. Now let's verify what we have here by the theoretical calculations, and then let's see. So what we can say is that from this particular circuit, we can say that I1 is equals to I2 plus I3 plus I3. Okay, so why am I saying that? Because you can see that the current over here is flowing here, and then also is flowing here. So you can see that I1 is being divided into I2, which is this part, and then it's also being divided into I3, which is this particular part. So that can be, so this will be our first equation. Our second equation, what we can say is so this first equation basically verifies the Kirchoff's current law, because we can also say that uh, I1 minus I2 minus I3 is equals to 0. This is the Kirchoff's current law, because the law says that the sum, or the algebraic sum of the current at a point is 0. So now you can see that the sum of the current is what? Is 0. Okay, so the first law verifies the Kirchoff's current law. Okay, so I'll leave the first law as it is. Okay, so the next one that we can write will be for our first loop. So this is our first loop. So we're going to write the voltage law for this particular first loop. Okay, so now with respect to the voltage law, what I can say is that 20 volts or 20 volts or 20, okay, is equals to, so now 20 is equals to, so now this 20, what I can say that this is one loop. Okay, so the current is coming this way. Okay, so when the current is coming, it's coming from positive and then it's coming to negative. Whenever the current is coming from the positive to the negative, in that case, the voltage here is positive and the voltage here is negative. So the voltage is going to be decreasing. In that case, our voltage is going to be negative. Okay, so I am going to have 20 minus the resistor over there. So the resistor over here is 220 ohms. So 20 minus 220, and then, so that is a resistance there. And then the current there, I'll call it I2. So this is what? I2 is equals to, should be equals to 0. Okay, so now let me go to the next loop. Okay, so this is the next loop. Okay, so with the next loop, I'm going to move from here, which is negative, and I'm going to go to the positive. Okay, so negative to the positive, that means that my voltage is going to be increasing, because I'm moving from the negative to the positive. Okay, so I'm going to have, uh, 220 I2 I2 minus, so then from there it comes here. So here is going to be positive and then negative. So positive and then negative. So I'm going to have 330. I'm going to have 330. So minus 330 I3. I3 is equals to 0. So now I'm going to solve these three equations. So after solving these three equations, I should be able to get the values that I got from what the circuit wizard gave me. Okay, so how can I solve these three equations? Okay, okay. So now here, that means that, sorry, I don't know how I could make this mistake. Wait a minute, let me just see. Okay, let me write my equations again. I just made some little mistake. I think I have to correct it. Okay, so the first equation was that I1 is equals to I2 plus I3. And the second one, I wrote 20. Basically, it's supposed to be 10, because you can see that our volt here is what, 10 volt. So I'm not supposed to write 20 there. I'm supposed to write 10. So I write 10 minus 220 I2 is equals to 0. And then the next one, I'm going to have 220 I2 minus 330 I3. Okay, I3. Okay, so if I should say that this one is, let's say, equation So I'll just solve these three equations, okay? I'll just solve these three equations and I'll be able to get the values that my circuit wizard gave me in the practical realization. Okay, so let me just make another box here. Okay, so if I come to the second equation, 10 minus 220, I2 is equals to 0, I can say that minus 220 I2 is equals to minus 10. Okay, so now when I do that, I'll get 10 over 220 is equals to I2. I2. Sorry, I'm supposed to write 2 over here and not 1. Okay, so this is what I'm supposed to have. So if I do this, then 10 over 220 is going to give me, let's just get a calculator and then see how we can just punch this one. So let's get a calculator. Okay, so this is a calculator. Okay, so let's say 10 over divided by 220, okay, is going to give us, is going to give us 0.04545. Okay, so that means that, let me just minimize it. So that means that I2 is equals to 0. We got 0.045. Okay, we got 0.04545. Okay, basically this is, so this is in what, amps. Okay, so we can say that this is equals to if we should move it 3 decimal places, then we're going to get 45.45 milliamps. Okay, so that's what we're going to get. And then, so after getting I2, we can proceed on to get I3. Okay, so let me just calculate I3, do the calculation for I3 over here. Okay, so with respect to I3, I can say that 220 into I2. I2, what is I2? 0 is 0.04545. Okay, then minus minus 330 I3. Okay, let me make the I positive. Okay, it's supposed to be equals to 0. I didn't bring the equals to 0 over here. I am sorry, but please be reminded that it's supposed to be equals to 0 over here. Okay, so when I do that, let's go back to our calculator and then see. So if I have, so if I have, let me get, okay, okay. So now let me say 220 times 0.04545. So let's see what we get. We get 9.99. Okay, we get 9.99. Okay, so let me just write over here 9.999. Okay, minus 330 into I3. Okay, so I can even erase my 9.99 from here, and then I can make it is equals to minus 9.9999. Okay, all right, so that is cool. So now what I'm going to have here on my calculator here is going to be 9.999 divided by 330. All right, so what do I get from there? I get 0.303. Okay, so that means that I3 is equals to 0. What did we get? 0.0 303. Okay, and this one is equals to, so this one is in amps. Okay, so in terms, so I can, if I move the decimal place into, if I move the decimal point 3 places, I'm going to get 30.30 milliamps. Okay, okay, good. Now I can also do, so now what about I1? I know that I1 is equal to I2 plus what? I3. So I can say that I1 is equals to I2 plus I3. And what is I2? I2 is 45.45 milliamps. Okay, milliamps. Okay, so plus 30.30 milliamps. Okay, so what is this going to give me? Let me punch it on my calculator. So here, I have 45.45 plus 30.30. All right. So if I do that, what do I get? I get 75.75. Okay, so that means that I1, let me make the I capital. I1 is equals to 75.75. Okay, so these are the values that we get from our theoretical calculation using the Kirchoff's voltage and current laws. So we get I1 to be 45. We get I2 to be 45.45 milliamps. We get I3 to be 30.30 milliamps. And we get I1 to be 75.75 also milliamps. Okay, so now let's come back to our circuit. So here also you can see that this is our I1 is 75.76 milliamps. It's just because of the decimal points. Okay, that in our theoretical calculation, if we had extended our decimal points into about 3 or 4 decimal places, we would have gotten it to be 75.76 milliamps, just as here, but we got it to be 75.75 milliamps, which is similar and almost the same as this one. That means we are correct. Okay, we got our I2 to be 45.45 milliamps, which is the same, which also means that we are correct. And we got our I3 to be 30.30 milliamps, which also means that we are correct. Okay, so that means that we have been able to verify the Kirchoff's current law, okay, using this circuit wizard circuit that we've constructed over here, and then using our theoretical calculations that we have over here. Okay, so I'll see you in another video. Enjoy your time. Goodbye.